Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. The subject is Statistical Methods 1, and in the previous sessions we have dealt with the random variables. The random variables 2 types, discrete and continuous, and the corresponding probability functions, probability mass function shortly PMF and probability density function PDF, and the respective cumulative distribution function and their properties has been dealt in the previous session. Now, in this session we are going to deal with discrete random variables. The outline of the session goes with, we are going to deal with some illustrations based on discrete random variable and the corresponding probability mass function and their corresponding distribution function, cumulative distribution function. If we deal with some of the illustrations of these topics, we will be able to understand the concepts very clearly. So, the first illustration goes with 2 dice are rolled. Let x denote the random variable which counts the total number of points on the upturned faces. We have to draw the probability chart and construct the PMF and CDF of x. When 2 dice are rolled, the sample points is as follows: 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. This represent the 1, 1 represent the point 1 on the first die and point 2 on the second die. Similarly, we have totally 36 possibilities of the sample space. Okay. X is defined as a total of the points. Seeing to the sample space, the point starts with 1, 1 and ends up with 6, 6. So, first starting point is 1, 1. When you add 1 and 1, it becomes 2. So, your x value starts from x is equal to 2, which is 1 plus 1, then 1 plus 2, 3, like that when you add, starting with 1, 1, ending up with 6, 6. So, x takes the values from 2, 3, 4, etc. up to 12. This 12 is 6, 6. Okay. So, x is taking the values from 2 to 12, which are finite in number, therefore, it represents the discrete random variable. When it represents discrete random variable, we have to talk about probability mass function. Okay. So, how to find out the probability mass function and the corresponding probability chart, we will see it now. So, as discussed, there are total 36 exhaustive events. For corresponding to x is equal to 2, let us see how this x is equal to 2 is being arrived. X is equal to 2 is arrived from the possibility 1, 1. Okay. So, 1, 1 only possibility which gives you x is equal to 2. So, out of 36 possibilities, you have 1, 1 which gives x is equal to 2. So, the corresponding probability for P of x is equal to 2 is 1 divided by 36. This is the probability corresponding to the random variable x is equal to 2. Similarly, if you take x is equal to 3, how x is equal to 3 is arrived? When you add 2 points on the die, it should come as x is equal to 3. It can be arised with 1, 2 and 2, 1. Another possibility gives you x is equal to 3. Therefore, only 2 possibilities are there. Therefore, the corresponding probability is P of x is equal to 3 is 2 divided by 36. This 36 is the exhaustive number of events. 1, 1 to 6, 6 is the total number of events which has 36. Okay. Similarly, when you go for x is equal to 4, x is equal to 4 is arrived with 3 possibilities 1, 3, 3, 1, 2, 2. So, correspondingly P of x is equal to 4 is 3 divided by 36. Likewise, we can find out for x is equal to 5, 6, 7, 8, 9, 10, 11 and 12. Like that it goes. For example, if you want to find out for x is equal to 10, x is equal to 10 is obtained with the possibilities 5, 5, then 4, 6, 6, 4. Any other possibility giving you x is equal to 10? Only these 3 possibilities. Therefore, the corresponding probability is P of x is equal to 10 is 3 by 36. Summarizing all these probabilities, when you put it in a tabular column, it becomes a probability mass function. This is what is constructing the probability mass function PMF. Write down what is the PM of fx, probability mass function of x. X is taking the values 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then 12. So, the corresponding probability values is 2 gives you 1 by 36, 2 by 36, 3 by 36, 4 by 36, 5 by 36, 6 by 36, then 5 by 36, 4 by 36, 3 by 36, 2 by 36 and 1 by 36. This is the probability mass function of x. Okay. Let us see how the probability chart is drawn for this problem. Okay. Take the x axis and the corresponding p of x axis. Okay. Mark it as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then 12. For here, what are the possibilities? 1 by 36, 2 by 36, 3 by 36, 4 by 36, 5 by 36 and you have 6 by 36. Corresponding to P of x, we have the x values, this is x axis, we have the x value starting from 2 to 12. So, for 2, the corresponding probability line is 2 to 1 by 36. Okay. Similarly, for 3 it is 2 by 36, for 4 3 by 36, for 5 it is 5 by 36, then 6 by 36, likewise for 7 it is 5 by 36, for 8 4 by 36, 9 3 by 36, 10 is 2 by 36, 11 and 12 is 1 by 36. This is the probability chart. Now, let us see how the cumulative distribution function of x is found out. Okay. X values is again 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then 12. The corresponding probability distribution function, cumulative distribution function is, you have to go back to PMF of x. Cumulative distribution function is adding up the previous values. Corresponding to 2, when you see at PMF it is 1 by 36. Corresponding to 3 it was 2 by 36. Therefore, when you add with the previous one it becomes 3 by 36. Then when you add with the previous one it is 5 by 36. Likewise, when you add you get the corresponding f of x for x is equal to 12 is 1. So, this is the cumulative distribution function of x. Okay. Hence, we have found out the PMF, probability mass function of x, then cumulative distribution function of x, and we have drawn the probability chart for the random variable x. Going to the next sum, let P of x represent the probability function of a discrete random variable x, which assumes the values 0, 1, 2, 3. Again 0, 1, 2, 3 are just 4 number which is finite, such that there is an expression of the probability functions. 2 times P of 0 is equal to 3 times P of 1 is equal to P of 2 is equal to 5 times P of 3. You are asked to find out the probability distribution and cumulative distribution function of x. Let us see how to find out the cumulative distribution function and probability function for this illustration. Okay. So, you are given 2 times P of 0 is equal to 3 times P of 1 is equal to P of 2 is equal to 5 times P of 3. All these can be taken as an equal to a constant k. Now, equate it separately. 2 times P of 0 is equal to k, then 3 times P of 1 is equal to k. Similarly, P of 2 is equal to k and 5 times P of 3 is equal to k. So, what happens? P of 0 is equal to k by 2, P of 1 is equal to k by 3 and P of 2 is equal to k, P of 3 is equal to k by 5. And we know that total probability is equal to 1. So, what happens? P of 0 plus P of 1 plus P of 2 plus P of 3, which is total probability is equal to 1. So, what happens? Your respective k values also should be added up to 1. K by 2 plus k by 3 plus k by 5 is equal to 1. This gives you 61 k by 30 is equal to 1. So, your k is equal to 30 divided by 61. These k values again should be substituted in the respective probabilities to get the probability function of x. Okay. So, if I write x values as 0, 1, 2, 3, the corresponding p of x values was k by 2, k by 3, k and then k by 5. Now, when you substitute the k value as 30 divided by 61, you get 15 by 61, 10 by 61, 30 by 61, then 6 by 61. So, this is your probability mass function of x being the k values being substituted. Hence, now we have found out the probability distribution of x. How to find out the cumulative distribution function of x? Cumulative distribution function of x goes with adding the previous values, right? X takes the value 0, 1, 2, 3. So, f of x is first is 15 by 61, then the second value was 10 by 61, right. So, you have 25 by 61, the previous value is 30 by 61. When you add 30 by 61 plus 25 by 61, you have 55 by 61 and the last one 61 by 61, which is 1. This is your cumulative distribution function of x, CDF of x. Hence, we have found out the probability distribution and cumulative distribution function of x. Let us now have a small break. Welcome after the break. Before the break, we have seen some illustrations dealing with the discrete random variables and to find the probability mass function and the cumulative distribution function of x. One example was dealt with the descriptive property of dice, and then we were asked to construct the PMF and draw the probability chart. And second problem, we have been given the probability relations between the probability functions. So, using the probability relations, we have to find out the probability mass function and the respective cumulative distribution function of x. Continuing with the illustrations, in this example, a random variable x takes the values 1, 2, 3 etc. up to infinity, and the probability expression is given as 1 by 2 power n. Here n takes the values 1, 2, 3 etc. up to infinity. Here also x is discrete random variables because this 1, 2, 3 etc. up to infinity gives you countable number of values. When you are able to count the values, it is called discrete numbers, therefore, it is a discrete random variable. Okay. You are asked to find out p of x is odd, x is less than or equal to 5 and x is divisible by 5. Okay. So, now the solution goes as first p of x is odd. What is meant by odd numbers? List out all the odd numbers from n is equal to 1 to infinity. So, listing out the odd numbers is p of x is equal to 1 plus p of x is equal to 3 plus p of x is equal to 5. These are all odd numbers, right, plus etc. it goes on up to infinity. X is equal to 1, x is equal to n is 1 by 2 power n. So, what is x is equal to 1? It is 1 by 2 power 1. What is x is equal to 3? P of x is equal to 3 is 1 by 2 power 3 and p of x is equal to 5 is 1 by 2 power 5. Like that it goes on up to infinity. Now, we have to simplify this expression to get a corresponding probability value for p of x is odd. Okay. So, when you take 1 by 2 outside, it goes as 1 plus 1 by 2 square plus 1 by 2 power 4 plus etc. up to infinity. This is equal to 1 by 2 plus 1 by 2 open a bracket 1 plus 1 by 4 plus 1 by 4 whole square to express this in the format so that a formula can be applied plus etc. up to infinity. Actually 1 by 2 square is 1 by 4, 1 by 2 per 4 is 1 by 16, that 1 by 16 I am writing it as 1 by 4 square so that we can apply it to a formula. Okay. What does this expression stands for? It is standing as 1 plus x square plus etc. up to infinity, and we have a formula for this infinite series as equal to 1 minus x whole power minus 1. Here x is the value 1 by 4. Okay. 1 by 2 is already out and the expression stands for 1 minus 1 by 4 whole power minus 1 is equal to 1 by 2. When you simplify it is 1 minus 1 by 4, it is 3 by 4 whole power minus 1, which is 1 by 2 into 4 by 3. When you simplify it becomes 2 by 3. So, what is that we have found? In the first one p of x is odd, we got the answer as equal to 2 by 3. This is over. Coming to the second subdivision, p of x is less than or equal to 5. Okay. What are the values which x can take? Less than or equal to 5 means p of x is equal to 1. X is equal to 0 should not be taken because x is taking the values only from 1, 2, 3 etc. up to infinity. You are not supposed to take x is equal to 0 although it is less than 5, because we have to take the x values which it assumes, plus p of x is equal to 2 plus p of x is equal to 3 plus p of x is equal to 4, then p of x is equal to 5. Okay. So, first one is p of x is equal to 1, it is 1 by 2 power 1 plus 1 by 2 square, second one 1 by 2 cube plus 1 by 2 power 4 plus 1 by 2 power 5. This is the summation of only 5 terms, it is not infinite series. So, for summation of finite terms, we have the formula a plus ar plus ar square plus etc. summation up to n terms. The formula goes like a into 1 minus r power n by 1 minus r. This formula is for summation of finite terms. Okay. Comparing this formula with the expression we have, a is equal to here 1 by 2 and r is the difference which is also equal to 1 by 2. Difference between r is the multiple ar. So, difference between first and second term is 1 by 2. So, r is 1 by 2. A is the first term which is also 1 by 2. Okay. Applying this formula for this series, we have this is equal to 1 by 2 into 1 minus 1 by 2 power, how many terms are there? 5 terms. Okay, 1 minus 1 by 2 whole power 5 divided by 1 minus 1 by 2, 1 minus r. This is equal to 1 by 2 into 1 minus 1 by 32, right, because 2 power 5 is 32 by 1 minus 1 by 2 is 1 by 2. When you cancel 1 by 2, 1 by 2, the answer, and this get simplifying this 1 minus 1 by 32, we have the answer as 31 by 32. So, what we have done? We have found out the second subdivision answer, P of x less than or equal to 5 is equal to 31 by 32. Going for third subdivision, P of x is divisible by 5, divisible by 5. So, list out all the values of x which are divisible by 5, which are nothing but multiples of 5. P of x is equal to 5 plus P of x is equal to 10 plus P of x is equal to 15 plus etc. up to infinity. Okay. X is equal to 5 means 1 by 2 power 5, x is equal to 10, P of x is equal to 10 is 1 by 2 power 10. All the expressions are taken from P of x is equal to n is equal to 1 by 2 power n. So, plus 1 by 2 power 15 plus etc. up to infinity. This is equal to, this is again an infinite series. So, I have to take 1 by 2 power 5 outside, gives you 1 plus 1 by 2 power 5. When out of 10, 5 is taken outside, remaining 5 remains 1 by 2 power 10 plus etc. up to infinity. So, this is 1 by 2 power 5, 1 plus 1 by 2 power 5 plus 1 by 2 power 5 whole square plus etc. up to infinity. Oh, here using the same formula of 1 plus x square etc. up to infinity is equal to 1 minus x whole power minus 1. Here x is equal to 1 by 2 power 5. Okay. Applying this formula for the series, we have P of x is divisible by 5 is equal to, already 1 by 2 power 5 is taken outside. So, 1 minus 1 by 2 power 5 whole power minus 1. Simplifying this, we get 1 by 2 power 5 is equal to 1 minus 1 by 32 whole power minus 1, that is 1 by 32 into 31 by 32 whole power minus 1. So, 1 by 32, 32 by 31, 32 gets cancelled, answer is 1 by 31. So, P of x is divisible by 5 is equal to 1 by 31. Now, this is an expression where you have a probability function being defined by a function where n taking the discrete values. Next illustration is a random variable x has the probability function, x is being defined as taking the values from 0, 1, 2, 3 etc. up to 7, and P of x is given as 0, k, 2k, 2k, 3k, k square, 2k square, 7k square plus k. You are asked to find out the value of k and evaluate certain probabilities, distribution, cumulative distribution function of x, and minimum value of a for which P of x less than or equal to a is greater than 1 by 2. Let us first find out k value. Again total summation P of x is equal to 1, that is adding 0 plus k plus 2k plus 2k plus 3k plus etc. whatever is given here plus 7k square plus k is equal to 1 gives you 10k square plus 9k minus 1 is equal to 0. This gives you the k value as 1 by 10 or k is equal to minus 1. K is equal to 1 by 10 or k is equal to minus 1. K is actually representing the probability value, therefore, k is equal to minus 1 cannot be accepted. We have to take only k is equal to 1 by 10. This k is equal to 1 by 10 has to be substituted back in this probability table, so that you get the probability mass function of x. So, when I substitute k is equal to 1 by 10, P of x becomes 0, 1 by 10, 2 by 10, again 2 by 10, correspondingly 3 by 10, k square is 1 by 100, 2k square is 2 by 100, and 7k square plus k is 7 by 100 plus 1 by 10, which is 17 by 100. Okay. So, writing this x as 0, 1, 2, 3, 4, 5, 6, 7 and writing the corresponding probability function 0, 1 by 10, 2 by 10 etc. up to 17 by 100 and putting it in a tabular column gives you probability mass function of x. Now, correspondingly we will find out the cumulative distribution function of x also, that is your capital F of x. So, cumulative is adding the previous values, adding all the previous values 0 and 1 by 10, 3 by 10, 5 by 10, adding all the previous values, then 8 by 10, 8 by 10 plus 1 by 100 is 81 by 100, then 83 by 100, then last value is 1. Now, we will deal with the last subdivision where you are asked to find out the corresponding value of a for which p of x is less than or equal to a is greater than 1 by 2. Okay. P of x less than or equal to a stands for f of a. So, you have to find out the minimum value of a for which f of a is greater than 1 by 2. Writing all the decimal values here 8 by 10, here this is 0.5, this is 0.8 corresponding of f of x, this is 0.81, 0.83 and then 1. So, when you see corresponding values of f of x is greater than half is 0.8, 0.81, 0.83, 1. The corresponding values are f of 4, f of 5, f of 6 and f of 7. Okay. So, we see f of 4 is 0.8, f of 5 is 0.81, f of 6 is 0.83, f of 7 is 1. All these values are greater than 1 by 2. So, the corresponding x values are 4, 5, 6, 7. You are asked to find out the minimum of x, minimum of this value of x. Okay. Minimum of x is equal to 4 is the value which gives you greater than 1 by 2. So, f of a is greater than 1 by 2, a is small, is nothing but a is equal to 4. Okay. Corresponding to a is equal to 4, you have f of a is greater than 1 by 2. So, the last subdivision is over. Now, going back to the second subdivision, you are asked to find out p of x less than 3. P of x less than 3 is nothing but p of x is equal to 0, p of 1, p of 2, only these 3 values. So, 0 plus 1 by 10 plus 2 by 10. So, answer is 3 by 10. All the values you can pick up from the probability mass function. Okay. Third subdivision, you are asked to find out p of x greater than or equal to 6. First p of x less than 6 you are asked to find out. Before finding p of x less than 6 gives you x is equal to 0, 1, 2, 3, 4, 5 which is very long. So, first let us find out p of x greater than or equal to 6. Although it is given in this order, first we will find out p of x greater than or equal to 6 and using the complementary event we can find out p of x less than 6. Greater than or equal to 6 is nothing but p of 6 plus p of 7, which is p of 6 is 2 by 100 and p of 7 is 17 by 100. P of 6 is 2 by 100 and this is 17 by 100. So, when you add 19 by 100 is your p of x greater than or equal to 6. So, how to find out p of x less than 6? P of x less than 6 is nothing but 1 minus p of x greater than or equal to 6 using the complementary event. So, 1 minus 19 by 100, this gives you 81 by 100. Another subdivision is you are asked to find out p of 0 less than x less than 5, that is the values between 0 and 5 not inclusive, 0 and 5 is not included. So, you have p of 1 plus p of 2 plus p of 3 plus p of 4. This p of 1 is 1 by 10 plus 2 by 10 plus 2 by 10 again and then 3 by 10. When you add, it is 8 by 10 is equal to 0.8. In this session, we have dealt with some of the illustrations of discrete random variables and finding the probability mass function, cumulative distribution function, and then constructing the probability chart. Some do it yourself exercise has been given to you. Probability mass function of random variable x is given below. You have to find out the value of c, again using total probability is 1, and find out the largest value of x for which f of x is less than 1 by 2, construct cumulative distribution function of x, and using the cumulative distribution function of x find out f of x less than 1 by 2 and f of x greater or equal to 1 by 3. And similar example where you have to find out first k, using the probability mass function evaluate these probabilities and find out the smallest value of x for which p of x is less than or equal to x, is nothing but f of x is greater than 0.5. Using the expressions equating it as k and find out the corresponding probability function of x and distribution function of x. Thank you.